It's the most wonderful time of the year. Nope, not that. It's time to go back to school. Set the alarm clock and sharpen your pencils because this week we are going off the radar and into the classroom to boost your earth science knowledge.
I love science!
We'll sit down with two experts to answer all your burning questions about the atmosphere.
It's fairly rare. Ball lightning is really a concentration of energy.
We'll uncover mysteries out in the ocean.
It's not like an island of trash or debris. It's more like a soup of scattered plastics of all different sizes.
And we'll bust some myths.
You pee on a jellyfish sting, it could make it worse.
So before the late bell rings, hop on this bus ride of fun, odd, and at times, out of this world discussion with Dave Jones and Ellen Prager.
I set the thermostat and she boils the water.
I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do.
With Audible, there's more to imagine when you listen. Whether you listen to stories, motivation, expert advice, any genre you love, you can be inspired to imagine new worlds, new possibilities, new ways of thinking. And Audible makes it easy to be inspired and entertained as a part of your everyday routine without needing to set aside extra time. As an Audible member, you choose one title a month to keep from their ever-growing catalog. Be inspired to explore your inner creativity with Viola Davis's memoir, Finding Me. Find what piques your imagination with Audible. New members can try Audible free for 30 days. Visit audible.com/imagine or text imagine to 500-500. That's audible.com/imagine or text imagine to 500-500.
Are you guys paying attention to me?
Yeah, we're both.
Don't worry about the screen. You're not going to be on TV. It's just audio that I'm recording. Okay? That's not even relevant.
This bit out.
Yes, we can edit this bit out. Listeners, in case you haven't picked up on this, I have my kids with me today because we're talking about back to school. Hi, guys. Are you excited to be on Off the Radar?
Yeah, I definitely am. My first hello.
I have Aaron, who's 11. Yeah.
Hello.
And I have Addison, who's 6, almost 7. Say hi, Addison.
Hi.
So Addison is in 1st grade. Aaron is in 6th grade.
Don't forget about Abigail.
And Addison's doll, Abigail, is here, too. Can't forget about her. What grade is she going into?
She's going into 2nd.
Oh,
she's 7.
Oh, wow. Interesting. She's small for her age. Are you glad to be back at school?
Yeah. Yeah.
All right. What's your favorite subject in school, guys?
I really like math. I'm really good at it.
Oh.
My favorite subject is probably technology. It's really good.
Yeah, because you get to use computers?
Yay.
What about science?
I love science. I got a science food book.
You got a science food book. What's in that?
That you can eat.
Ooh. Aaron, what's your favorite part of science?
I really like the meteorology aspect with my mom.
Somebody's trying to play video games tonight.
Yay!
Okay, so today is going to be all about science. We're going to talk about ocean and atmosphere and earth science and a little bit of space. Which one do you want to hear about the most?
Space, definitely. I'm a real space person.
You are a real space person. Do you remember you used to come on TV with me and you would give little facts about space?
I guess it's been a while.
So, any fun facts that you want to share with me about science?
You might already know this one, but the largest mountain in the solar system currently discovered is Mount Olympus Mons on Mars. I don't know the exact height, but it's quite big.
Do you have any science facts for me, Addison?
Well, Mommy, did you know that there's this planet and how to draw and like how people draw is they just draw little dots and color it in and they're like stuck together like that. And I forgot the name of it, but my friend Della told me about it.
Oh, cool. We'll have to do some more research on that one. Or we could ask the two experts that I'm going to have on the show today. Their names are Dave Jones. He's a meteorologist. And Dr. Ellen Prager. She's an oceanographer. Yeah, ocean. So cool stuff. They have some cool facts. They're going to talk about mermaids. Mermaids! Yeah, and Aaron's rolling his eyes. And megalodons.
Oh, that one I want to hear about. That was real. That's more realistic.
And climate change.
Yay! Climate change!
Of the three of those, which one do you think exists today?
Oh! Climate change. Definitely climate change.
Well, they wrote a book answering all these questions. We're going to talk to them today. Aaron, Addison, thank you so much for coming on the show with me today to intro this amazing episode with Ellen Prager and Dave Jones. Do you have anything else you want to share before we
just got here?
This is what the intro is all about, sweetie. It's just supposed to be a short little intro.
Oh.
Anything else you want to add, Aaron?
No, not really.
All right. Say goodbye to all our listeners.
Bye-bye.
Dave Jones, Ellen Prager, thank you for coming on Off the Radar. So glad to have you both.
Oh, it's great to be here, Emily. Thanks so much. It's very exciting.
It is. We love talking to you, and this is great. Thank you for having us.
Of course. And you guys are no strangers to not only Off the Radar, but also the National Weather Desk. Both of you have been on both shows at least a few times. Dave, we talked to you about space when it came to the solar eclipse last year. And then Ellen, we talked about the submersible that went down. Remember, you were on the show then. And then, of course, you help us out when we have these little science stories that pop up every now and then. So glad to have both of you experts on the show. I want to talk a little bit about your backgrounds because, Dave, you have a very similar background to me. Broadcast meteorology is what you did for many years, but you go back even farther than that. And I was reading the intro to the book and I learned something about you. And I'm curious, I think we have something in common. Do you know that I used to teach meteorology at the Community College of Baltimore County in Catonsville?
You did? Oh my gosh. No, I didn't know that.
Is that the community college that you used to ride your bike to when you were little?
It is, exactly. Yeah, it used to be then Catonsville Community College. Yeah.
So, yeah, I taught, and it's funny, I taught aviation students. So their intro to meteorology class was in the aviation program.
Oh, nothing's terrific.
And that's so fun.
I know, right? And then, Ellen, your background, I was so intrigued by as well because it's so impressive. Can you give me a brief background on what you've done over the past several decades?
So, I always like to laugh and say that I really thought I was going to be your traditional researcher, teacher at a university. And I love science and I love research. And I started doing that in graduate school. But what I discovered is I really love teaching and people and writing for the layperson. So after I got my PhD, I worked for Sea Education Association, where I took students out to sea for 6 weeks to teach oceanography on board a tall sailing ship out of Woods Hole. So that was really cool. I ran a marine lab on a remote, small island for a little while. I was the assistant dean at the University of Miami graduate program. And of course, I was the chief scientist for the world's only undersea research station, and did 2 missions where I lived undersea for a week or more, which, that's great. And then probably my claim to fame is that I was a consultant on the Disney movie Moana on all things ocean.
I had that in my notes because I thought that was so cool. How do you consult on a Disney movie? Like, what does that involve? What's real about Moana that they needed your expertise?
Well, so think about the animators and the producers when they were depicting the scenes in the ocean and how the characters interact with the ocean and what could happen in storms and reefs and what about at night. They didn't know any of that. And so I talked to them on a video call, but then I actually was giving a talk at the Aquarium of the Pacific and offered to go to Burbank. So I went to the studios and they had a big auditorium and they had all their animators and producers come. And I gave them a talk and I showed them slides about how the ocean can look under different conditions.
Oh, awesome. Okay, so Dave, I want to hear about you too, because broadcast meteorology is like this very small sliver of your past. And can you give me a little brief history of you and how you became a meteorologist and then what you do now?
Sure. Well, I mean, back when I was 6, I saw lightning strike a tree across from my parents' house, and then after that lightning struck the tree, I saw ball lightning come out of the tree and come across the street, sort of headed for my window. At least it looked like when I was 6, and then it just kind of like disappeared up into nothing. It just went away, and that was it. That got into my DNA. I've got to figure out everything. How does lightning form? What do thunderstorms do? My parents got me a police scanner so I could listen to them responding to thunderstorms and damage reports after storms would move through and stuff like that. So, when I got into college, I went to University of Maryland and ended up working, being hired as an intern at NASA at Goddard Space Flight Center. And I helped the company start in the Pacific Northwest. I worked for a computer weather graphics company, environmental satellite data, ESD. It was before the days of all the fancy systems that WSI has now. But we worked a lot with broadcast meteorologists around the country. I would travel around and train them how to use the systems and hold workshops and all that kind of stuff. So communication and meteorology, I think, are in my blood.
And something that's in both of your blood is questions and asking questions. I mean, the first time I saw the two of you together was at the AMS meeting in Phoenix, when you were given your own microphone at one point, because at the end of every single presentation, you had questions. But, now I kind of understand why, because you learn so much from asking these questions, and everybody has more knowledge. And that seems to be the theme of this book that the two of you wrote together, is ask questions and get answers. So how did this kind of idea of writing this book come from, and then the theme of what it would be?
After I wrote my last popular science nonfiction book, I said to Dave, this is a lot of work. If I ever say I'm going to do another one, it just smacked me over the head. And about a month later, I don't know if it was because we both love asking questions, and we always talk about the fact that when you go to a talk, if you're giving a talk and nobody asks questions, it's like, wow, did anybody really pay attention? Did they care where they're engaged? And if you go and you see speakers, they're waiting for somebody to ask a question. And so it's really important to ask questions. And I'm not sure if our discussions about questions was what sort of came up with the idea. But then I said, that's a really good idea for a book. And he's like, didn't you just tell me to tell you not to write another one?
And, it was great because when we hear talks, we do have a lot of questions. And when we ask those questions, speakers are really appreciative, that you've listened to what they had to say and you've asked those questions. And so, Ellen and I just started talking about, we kind of get wacky questions ourselves, after I would get off the air, and at NBC in Washington, I would get calls sometimes with people asking me some pretty bizarre questions. And it's like, we could probably, Ellen would get them too after her presentation.
Yeah, I've done a ton of public speaking with some of my other books and things in schools, nature centers for all different ages. And it's funny because sometimes what happens is everybody's really quiet and nobody asks questions. Then one person will sort of ask a question. Then everybody else feels comfortable. But I remember I gave this talk about one of my previous books, my Sex, Drugs, and Sea Slime. I had really funny sort of things in it. Nobody laughed in the audience. No questions. Nobody laughed. And I was like, oh my God.
Am I on mute?
I was like, I said, oh, this is terrible. Then I was doing a book signing. People came up after the talk to get a book. And they kept saying, that was so funny. I learned so much. I'm like, but so sometimes people are really shy about asking questions. And one of the messages we want to send to people is, no, don't be shy. It's really important to ask questions. It makes the speaker feel better. It knows you're engaged. It also makes us look at things in a different perspective. Because sometimes you get questions and you're like, wow, I never thought of it that way. And so it's really important that people ask questions. And that was kind of the theme. And then we started thinking about, what are the most frequently asked questions that, we and our colleagues get, but also what are the zaniest ones, and, how we could have some fun with that too.
Okay, so I've got an atmosphere expert here. I've got an ocean expert here. I have questions. Can I ask you guys some questions? Will you answer them?
Go for it.
All right, I feel like you opened the door, so now it's happening. All right. First of all, can you tell me the name of the book? Because this is very interesting.
Megalodons, Mermaids, and Climate Change. Answers to your ocean and atmosphere questions.
Nice. Do people really think mermaids exist?
They do. So, unfortunately, Discovery Channel several years ago had these two, what we call mockumentaries. One was about mermaids, like the hidden body found, that it was a government cover-up, but that mermaids were real. And they did the same kind of thing with megalodons, and they had fake scientists, they had doctored videos, and honestly, people believed them. It was crazy. I would give talks, and people, they'd say, "Oh, well, you just said only less than 10% of the ocean has been explored. How do you know that mermaids are not down there?" So, yes, because of those fake shows, people thought mermaids were real. Same thing with megalodons. They thought because of these shows that it was a cover-up, that they were still swimming around in the deep sea.
Okay, to be clear, there were megalodons, right?
There were, millions of years ago, it was the largest shark ever, size of a school bus, bigger than great whites. But we know, based on scientific evidence, that they are extinct. And so they are not swimming around anymore in the deep sea.
I will say, where I live near Folly Beach in South Carolina, they did like a beach renourishment a few years ago, and people were finding what they were saying were megalodon teeth. Is that possible? Is that real?
Yes, they're fossilized. They're usually, when you get them, you see them and they're black, so they've been fossilized. And that's one of the sort of pieces of evidence that there don't exist today, that the only megalodon teeth they find are fossilized. And think about this. Sharks basically create and drop 40,000 teeth a year. If megalodons were swimming around, we would find some modern megalodon teeth, but they have found none. They're all fossilized.
I am curious though, because I have heard that we know more about space than we know about our own ocean. Is that true? And if so, what could be out there that we don't know about in the ocean?
Well, so there are a lot of aspects of the ocean that we haven't seen firsthand or even mapped. The deep sea, a lot of the mapping is done through satellite altimetry, and it can only resolve things that are like a couple miles big or high or wide. So think about anything smaller than that cannot be resolved that way. You have to go down with an ROV or submersible or a sonar system. And we haven't done that for most of the ocean. And so we know there are probably hundreds of thousands of seamounts that haven't been mapped. In terms of species, we know there are a lot of, every time somebody goes to a remote place, they discover new species. Now, we're probably not going to find too many big things, but there are a lot of small creatures and certainly microbes and things that have not been discovered yet. So there's a lot still down there that we haven't seen.
Gotcha. Okay, well, one thing we can see when flying over it, I guess, is the Great Pacific Garbage Patch. I had never heard of this until I think I saw it on How I Met Your Mother years ago. They were talking about this and how the main character couldn't sleep at night because of the garbage patch. So I'm picturing this big island made of garbage. What does this actually look like? And why is it a mystery? Because it's just floating on the surface of the water, right?
Yeah, it's not really a mystery. We know it's there. It's been known for quite a while. And the thing is, it's not like an island of trash or debris. It's more like a soup of scattered plastics of all different sizes. Hundreds of thousands of miles long and wide. What it is that the way the ocean currents work in the North Pacific and in North Atlantic, South Atlantic, are there these huge gyres that are basically spinning. Think of them as spinning currents. And the way it works is they spin and they collect material, gets pushed to the middle, and it gets collected there. And there's no way for that material to get out. So all the stuff that's coming in off the land, that's going off of fishing vessels, aquaculture processing, all of that ends up going into this gyre system and going into the middle, and that's where it collects. And again, it's not just a trash pile. It's scattered throughout the water column in all different sizes and pieces. And, I think in the book, I talked about how NOAA estimated it would take, something like 97 ships over however long to clean up. Very difficult to clean up, to pick it all up. So not only do we have to take the plastics that are in the ocean out, we also have to prevent it from getting in. So it's just as important to prevent those plastics from running off into the ocean.
Okay. And then I love this conspiracy theory, and it's like a real bummer that it's not working out for me. The Bermuda Triangle. You're raining at my parade here because I'm so intrigued. I'm like, I don't know, something about plane crashes and like things at the bottom of the ocean are very interesting to me.
Well, think about it. And Dave, you can chime in here think about when most of those reports have been made. It was before satellite imagery. So we didn't know where hurricanes were. We didn't know when they were coming, right? We didn't have GPS for navigation. We didn't have, and there are a lot of things we didn't. We didn't have computer models to forecast the track of storms.
It's also interesting too that, in the recent AMS broadcast meeting, right? We had a couple of talks on space weather. And so there could have been a coronal mass ejection at that time, which messed with instruments. That were on the planes, and they could have said, "Hey, they didn't know they were out of gas." Whoops.
Yeah, so, I mean, even today we hear about ships going down because they get caught in storms. So even today we hear, but not as many. But again, part of it is because of that area is very prevalent for squalls, hurricanes, downdrafts, because of where it is, and people just didn't have the instrumentation to detect them or to navigate very well. Plus, there's this great book out there. I have it referenced about this guy who went through all of the incidents that have been reported and found that not only a lot of them, most of them were weather related or ocean related, but a lot of them were like, they might have actually not even happened in the Bermuda Triangle, or a boat slipped off a mooring, or it was human error. So you can really debunk most of it.
I want to hear about the creatures that lie beneath too, because, we kind of talked about sharks, but there's other stuff down there that people are scared of when they get in the water. And this is something you guys talked about at the broadcast meeting. And once again, from pop culture, if a Friends episode tells me to pee on a jellyfish sting, I'm thinking this is probably right. So is that true? Should you pee on a jellyfish sting?
No.
So not all... Is that totally disgusting?
Gross.
It's about chemistry. And if you pee on a jellyfish sting, it could make it worse because two things cause the stinging cells to fire. Contact with skin or anything really, but contact or a change in chemistry such as pH. And your urine does not have the same pH as salt water. So peeing on a sting could cause more cells to fire and make it worse. So you don't want to rinse it with fresh water. You do not want to rinse it with pee. Mm-hmm. Basically, salt water, vinegar can help because it's a little bit acidic. That can help. And then take the tentacles off, and then you want to deactivate the venom with heat. But say no to your friend if they offer that.
Okay.
Lifeguards have vinegar. A lot of them often have vinegar on the lifeguard stands in case you get stung.
Yeah, and I think they have heat packs too, because isn't that the same remedy for stingray if you get stung by a stingray?
Same thing. Because the stingray in their barb has venom as well, and the heat can deactivate it.
Gotcha.
Yeah.
Okay, I want to ask Dave about some of these visual phenomenon that we've heard of, but we don't really know what they are. You mentioned ball lightning and what it looked like, but can you tell me how that happened?
People are still studying it because it's fairly rare. Ball lightning is really a concentration of energy because a lightning strike is so intense and so hot, and it has so much voltage, electricity with it. That occasionally, sometimes you see sparks that bounce, but occasionally there are these balls of energy.
Yeah, it's plasma. It's the lightning strike energizes the particles and they become plasma.
Yeah. And so it just sticks together, but not for long.
It's kind of like St. Elmo's fire, and it's almost like the neon in, lights that used to have neon lights. Mm. And it's the chemistry inside the neon is similar to plasma. And so ball lightning is a very particular kind. but it's not really well understood.
It can go through glass without breaking it and things like that.
So can you explain what St. Elmo's fire is?
So it's the same kind of phenomenon, except for instead of creating balls of lightning, it could hit a mast. It's very common in sailboats, like lightning hits a mast where the air is very charged. You'll get the same kind of plasma floating around the mast. And it's a glow.
Yeah, it's a glow. You don't even need lightning to hit the mast of a sailboat. It's just the charged particles in the atmosphere and the air that kind of hover around this big metal pole sticking up.
St. Elmo's fire it's not dangerous.
Yeah.
Really?
Yeah.
Mm-hmm.
You would think anything associated with lightning would be dangerous.
Yeah, I know, but it's really just the energy. It doesn't mean you're about to get struck, like if your hair stands straight up. It's just something that you can see. And if you're like out on the deck of the boat and you look up there, you might see it at times.
But if there's a thunderstorm going on, we should be inside and we should not be in a tub or running water or blow drying our hair.
That's right. That's right. Exactly. When there's a thunderstorm out, and my brothers and sisters used to call me and say, there's a storm coming. Do I have time to take a shower? I say, well, how fast can you shower? And you don't want to be in the shower when a thunderstorm happens, because there's always a chance that lightning could strike the house, near the house. The charge could go through the plumbing, and it could strike you or give you a shock, if you're in the shower. So it's always best to just shower when it's not storming out. And all the safety rules, stay away from windows and things like that. So
when the thunder roars, go indoors.
Go indoors.
Yeah, my kids say that all the time. Okay, so two things that I was taught when I was little and then until I grew up didn't know were wrong. One of them being the reason that we're safe inside a car from lightning. I knew we were safe inside a car from lightning, but I thought it was because of the rubber tires. It's not true, right?
Right. No, you're really in a cage that's metal around you that's really taking the lightning and dissipating it. So you're much safer inside of a car than if you see a storm coming and you say, "Oh, I got to get out of here."
The other thing was that when I was little, we always thought that the distance the lightning was from where you were was 1 second per mile or 1 mile per second.
Yeah. So when you see a lightning flash, then you start counting seconds and then you divide by 5. And so that's how many miles the storm is away, because the speed of sound is different than the speed of light. And so, when you see lightning in the distance, and of course, then if you don't hear.
Oh, this was one of my favorite ones because I learned something.
Heat lightning.
I thought there was such a thing as heat lightning, and Dave was like, "No."
Everybody does, Ellen. You weren't alone.
The first time Ellen saw lightning and didn't hear the thunder, she said, "Oh, that's heat lightning."
Oh, did it?
And I said, "Let me get something straight right now before we go out any further." No, but my brothers and sisters will always still say, "We're sitting out on the porch watching the heat lightning." And I'm like, ugh.
That one drives me crazy too.
What lightning is and what people call heat lightning is simply a thunderstorm that's a great distance away. So you see the lightning, but there's too much moisture in the atmosphere that it absorbs the sound before it gets to you, so you don't hear the thunder. There's always thunder associated with lightning. It's just that the storm is far enough away that sound does not reach you.
So we shouldn't call it heat lightning. We should call it humidity lightning.
Yes, right. Yeah, high dew point lightning.
Moist lightning. You know what I always got when I was a broadcast meteorologist, and people still ask me this, and I know you guys consulted with other people, like, what questions do you get asked? And this one, I was like, yes, I got this all the time. People always ask me, what's the difference between partly cloudy and partly sunny?
Yeah, I mean, there are these definitions of partly cloudy and partly sunny, but I always like to use partly sunny during the day and partly cloudy at night. So there's a difference in the cloud cover. How much?
It's like 3/8
percentage of clouds are up there. But it's like no. We're just going to make this very easy, and we're going to call it partly sunny during the day and partly cloudy at night.
I always just said, it's the same. It's the same thing. I simplified it perhaps a little bit more than I should have. Another one that I get is, why are these hurricanes coming at us? Like, why can't we do something about this? Can we like drop an iceberg in front of one or throw a nuke at it? Like, tell me about people trying to control hurricanes and the truth behind that.
Oh, yeah. Well, I mean, there's a lot of people that come up with their theories and their ideas of why can't we just do this and that? And one of the biggest ones is, why don't we just nuke it? Why can't we just nuke it? And that would have very bad effects outside of the hurricane. And it probably wouldn't disturb the hurricane either. So you don't want to throw a nuke inside of a hurricane to try to blast it apart. That would bad ramifications. Other people are thinking, well, if it needs warm water, if a hurricane needs warm water and it needs 79-degree water temperatures or above to form, why don't we just tow an iceberg into the Gulf of Mexico and cool the Gulf of Mexico up? There, it'll be cold enough where no hurricanes will form. Well, try scaling that up and scale that up to the size of the Gulf of Mexico. And how in the world are you going to tow an iceberg from the Arctic Circle all the way around to the Gulf of Mexico? So that's something that's a little bit unrealistic. And then there's also why don't we create an oil spill in the Gulf of Mexico? And that will stop the water from evaporating and going up into the clouds and giving the hurricane energy.
That's the worst idea I've ever heard.
Worst idea. And it's the worst idea. And we think we kind of tried that, right? There was a big oil spill in the Gulf of Mexico. Again, the scale of, I think that's the biggest thing for people to understand, is the scale of weather and what it takes to form and how much energy.
Right. And we understand the desire to stop hurricanes.
Yeah.
Absolutely. Yeah. And so, maybe in the future there'll be something, and we just haven't come up with the right answer yet.
Well, I mean, we see them getting stronger. We see them rapidly intensifying close to the coastline. All these things are very serious, and people are trying to think of all sorts of ways that we can try to prevent it. But unfortunately, I don't think we can.
Well, that transitions into the third portion of your title here that I want to ask you about, which is climate change. And I like this because it's like, people don't always know where to get climate change information or that it's reliable. So I like that you guys really broke that down in this book, kind of gave us the basics, but then also gave further resources on where you can get more information. But I do like that you kind of started with the simplest of, we used to call this thing global warming. And then at some point we started calling it climate change. Can you explain why and what the difference is here?
When you talk about global warming, you're just talking about the rise in global temperatures, air temperatures. But climate change is so much more than that. We know that it's causing sea level to rise because of melting land-based glaciers and ice caps. We know that it's causing the ocean to become more acidic. We know it's causing more extreme weather and wildfires, intense wildfires. So if you look at all the extreme flooding events we've had, precipitation events, if you look at the scope of everything together, that's what we call climate change. If we're talking about just global air temperatures, that was what was referred to originally as global warming.
All right. Well, let's talk about the sun. And I know, Dave, you love this topic, or at least you've gotten the reputation as loving this topic because of your involvement with NASA since college, clearly.
Yes.
But the sun's really having a moment here lately. We had the eclipse. Can you tell me about the impacts of space weather on Earth and why this is something that should be on our radar?
Yeah, the sun, I mean, first of all, a lot of people think that the sun controls the climate here on Earth. And, we dive into that a little bit in the book, too, by showing that the sun's intensity has actually gone down a little bit, and which means we should be cooling, but the Earth is warming. But the sun does a lot of other things and impacts a lot of other technologies and operations between the Earth and the sun. And so, we have to monitor what's going on in the sun. And it's we don't have a lot of instruments out there doing that right now. We have some satellites. NASA has satellites out there. But it's important to see when that sun is active. And, when you see a sunspot on the sun, and if you have eclipse classes, they're not just good during an eclipse. You can also use them during the day, and you can look at sunspots and see how many are out there. there are disturbed areas on the surface of the sun, and it's where coronal mass ejections develop from. And so if the sun is sort of pointed towards the Earth and a sunspot is lined up with the Earth and a coronal mass ejection happens and it starts heading towards the Earth, we have to think of all sorts of things. GPS. Everybody uses GPS for navigation to get from here to anywhere in their car. That could be messed up. So it could tell you to take a left on a bridge. Don't do that, right? And so you don't want to do that. It might mess up precision farming, right? Where you're trying to do precision agriculture because they have GPS systems on their tractors and they specifically say where to drop fertilizer, where to plant seed and all that.
And that happened in one of the last big geomagnetic storms. The farmers stopped planting because of the problem with the GPS. They stopped because they couldn't direct it all. And one thing we should just make also clear is what is space weather? Yeah. Right? Because everybody thinks it's just out in the middle of space, but it's not. It's only between the sun and the Earth. It's what happens between the sun and the Earth. That's called space weather. It's not everything out there beyond that.
Yeah. And we have astronauts out there in the space station, and they are very susceptible. If they're outside doing a spacewalk and there's a coronal mass ejection and these high speed radiation particles, gamma rays, things like that, hit them, that could be deadly. And so it's really important to monitor what's impacting the space. Yeah. Power grids. There was a big event that created big power outages in eastern Canada because this coronal mass ejection, when it hit the Earth, it created such an electrical charge around the Earth that it overloaded some of the power grids. And that's always a threat. We have to keep watching.
And one of the things that I learned, which was really interesting, is satellites in low orbit. If they're in low orbit during one of these things, they could be fried up. And in fact, there was one big geomagnetic storm that
2022
in 2022, and what was it?
It knocked out 28 Starlink satellites. The Starlinks that give us internet connectivity.
They launched them at a time right before this event, and it fried them.
Well, they were up there orbiting, and they're so small, right? They're small sats. That's the big thing. Get these small sats up there because they're cheap, and we can put a lot of them up there. Unfortunately, they don't have the protection systems that the big satellites like GOES or the NOAA polar orbiting satellites have. They can close the doors and put them sort of in a radiation safety mode. But you can't do that with small sats. So the sun could really have a big impact on things that we're starting to rely on.
Okay, so we've kind of gone into space and the sun. I want to come back to Earth and ask about something that I feel like my husband asks me about this all the time. The green flash. Can you explain the green flash? What causes that? Is it as amazing as it sounds?
Have you ever seen one?
No.
Okay, so first, sometimes people say it's not real. And I always say, go online. There are actually now some really good videos and images. And what I've seen a couple because I spent a lot of time out at sea. And the best conditions to see it is an open horizon, no clouds over the ocean. That's the best chance to see one as the sun is setting. So as the sun goes below the horizon, if the conditions are perfect, you might see just this very quick, almost instantaneous flash, a little flash of green as the sun departs. And it has to do, it's a little complicated. So we tried to explain it simply in the book, but it has to do with the refracting of the sun's rays and splitting them into different colors and wavelengths. And the smaller wavelengths, like the blue and purple, get scattered. So they get scattered really quickly as they refract. The longer wavelengths go past where you would see them, like red. But the green wavelength is like the Goldilocks of wavelengths. And it's just the right wavelength that when it gets refracted, it's in your vision, it's in your sight. And you need also the fact that there's an optical illusion that makes it look bigger because of that. So it's a combination of things, but it's that refraction and because as the sun is going down through the atmosphere and the wavelengths of light that get split up. And I will say, for me, years ago, I went to this great talk, and this guy had retired, and he set up a time-lapse camera it was in Florida from his condo to watch sunrise and sunset, to watch for the green flash. It was the most amazing thing I've ever seen. And so anybody who didn't believe that it was real just had to watch that. It was really
And you just need those special conditions,
Like, what are there any certain weather conditions that are better than others?
Well,
for
you're
it?
looking through the whole atmosphere, right? When the sun goes down, you're looking through the atmosphere. So things have to line up kind of correctly. It's almost like, no snowflake is the same shape, right? You need these special conditions for the green light to reach you and the distance from where you are to seeing that green light. Because some people see the flash if they're higher up in a high rise, because they have a little better angle and you might not see it even from a surface. If you're having trouble seeing it, then perhaps a margarita can help.
Oh, no. Okay. But I live on the East Coast. So can I see it at sunrise too, or is it just sunset?
Nope. It does happen at sunrise, but it's rarer than at sunset. But
Okay.
I saw videos. This guy had videos of it during sunrise. And I bet if you went online, you'd find some videos out there. It can happen
And
at
there's
sunrise.
videos of aliens online too. I need to see this for myself. The internet said so.
Credible source. Yes. Trusted information is what we're all about.
Yeah, so I want to ask you about that and kind of the overall theme of the book. This misinformation. What's the goal here with this book? What did you guys want to accomplish?
So there's a lot of misinformation out there right now, and it spreads so fast because there's so many sources, some credible, some not so credible. Like you said, you can Photoshop anything. You can create new, videos. And so we want people to question what they see, what they hear. Where does that come from? Is it from a scientist who studies that for years and has done a research and the, paper's been peer reviewed? Or is it somebody's opinion or idea? Those are two different things. And sometimes people don't think about that. Like they'll see a blog and they'll say, oh, I read this blog. Well, a blog is not data. It's not a scientific study. It might not come from somebody who's even an expert in whatever field it is. And so it's really important to look at the source of information. Is it based on data or is it based on just somebody's ideas?
Yeah.
Those are,
and there's with social media, I mean, the weird and wacky things get shared. They're the things that get all the views, right? The people who go out of bounds and talk about things and maybe sound like they might know what they're talking about. And so the overall theme in the book is really, look into things that you hear, ask questions, right? Ask more questions and try to find studies, try to find research that has been done before you just share away, and get this misinformation out there.
Something else I love that you put in there was the importance of this relationship between ocean and atmosphere too, how everything's kind of working together. And it's so cute because it's also you guys as human beings. I adore you as colleagues, but I also adore you as a couple. Can you tell me what it's like sharing a home, sharing a relationship with someone who's equally inquisitive and equally scientific? Do you guys just talk about ocean and atmosphere all day long?
I set the thermostat and she boils the water, so that's...
How many times have you used that one?
I mean, it's great because, when you meet somebody who is also a fellow scientist, but has a different, areas of expertise, it's fascinating, right?
and we ask each other questions because I'll see something like atmospheric or weather and we both are like, oh my God, did you see this? And do you think that's real? And one of us will go, do some research on it. So we're always looking at stuff like, oh, did you see what happened? And so we ask each other questions and we bring stuff to each other that maybe the other person hadn't seen. And we're like, oh my God, this is what I just heard. It's a lot of fun. I mean, and, we sort of liked, as you can sort of tell, we like to laugh. And so one of the things in the book that we really had fun with was the illustrations. And we haven't really talked about them, but we have graphic illustrations and we would come up with these ideas and then we'd go to the illustrator and say, hey, we've got this idea for one of these, fun sort of cartoon-like illustrations. And she would give us back and we'd be like, that's not a lenticular cloud. That looks like a spaceship. And so, but we worked a lot together with coming up with ideas. And of course we'd be laughing really hard. And then we're like, I wonder if anybody else will think that's funny.
So it's funny that you bring up the illustrations because I was reading it over the weekend and my 11-year-old son kind of leaned over my shoulder because he saw what looked like a comic book,
Right.
that I was reading. He was like, "What's that?" And then he looked at it and then he laughed. So I'm curious, are children like an audience that you're hoping to gain with this as well?
Target is sort of high school and above, but I think like middle schoolers, I think it'd be a great book for teachers, educated, for parents to read with their kids, show them, it's
middle schoolers
fun.
too.
Middle school. So it's not, it's not really our target age, but I think it would be great for that. We do want educators, science communicators, people who probably get asked these questions all the time. Like imagine if you worked at a museum, right? Or an aquarium, you probably get half these questions, and having at your fingertips really, because we spend time making sure the answers were credible. We have our sources in there. Having that at your fingertips would be so helpful. Think about a school teacher in earth science or, teaching earth systems.
Or some teacher they asked to teach earth systems that has never done it before.
Right.
So
yes, we have a lot of audiences, but certainly for kids. And I think some of, okay, we're a little snarky in some of our answers, which of course the kids would like. So I think they could get a lot out of it.
Yeah, I think so too.
I keep telling Ellen, I want to see this book in every airport bookstore around the country. Because I think that everybody they'd look at it, I'm delayed or whatever. I'll say, that book looks cool. Look at that.
You know what I like about it is I feel like anybody who reads it would nail any sort of earth science Jeopardy category after they read it. It's quick information. You're not droning on about anything. You're throwing important facts at people and you just take in so much all at once. So much more interesting than anything I read in school.
It's great. That's kind of what we didn't mean to, we had no intention of writing a textbook or going into in-depth on any one topic. And we even say that. We said, look, we want to make it engaging, but give you the answers. And we hope that if people want to know more, we gave people places to go to learn more. So you really describe what our intention was with it, was to make it a fun, pretty quick read. And, you could read it all at once, or you might pick up one, a chapter here or there, questions here or there.
Yeah. And Ellen said to me over the weekend, she's like, come here, let me show you something. And so she went on to Amazon, right? And she pulled up the book and it said, #1 new release in atmospheric science. I mean, it might have been the only release in atmospheric, but it's the #1 one.
But is it out yet? How and when and where can we get it?
They're pre-ordering, so that's what Amazon is starting.
So we can go on Amazon right now and buy this.
You can go on Amazon and pre-order. You can go to Columbia University Press and pre-order. Essentially, any bookstore will have access to it, and you could pre-order it.
So when is it official? When's the official release?
October.
Yeah, I think it was October 22nd, but Amazon is saying October 15th. So it's October. So
somewhere in October.
Cool. But Ellen, this is not your first book and definitely not the first one for children. You have a whole slew of these books, fiction books that are so fun. Can you give me a brief little overview of what you've written in the past?
Right. So this is nonfiction. We call it popular science, so high school and above. But I've also written young children's books, which are between 4 and 7, sort of children's illustrated. I have National Geographic sand, volcanoes, earthquakes. And now I have one with Arverdale Press called Sea Slime. It's ooey and gooey under the sea. And it's all about how animals use mucus underwater, which is kind of fun. But then I also have, it was interesting because I had those and I had popular science and I had some educators say to me, hey, you don't have anything for middle schoolers. And I was like, oh, you're right. And then I did my homework to figure out what they like to read. And, think about Harry Potter, Percy Jackson. They're all these adventure fiction books. So I have 2 sort of eco-adventure humorous series for middle schoolers that integrate science and nature into the stories. One is called Tristan Hunt and the Sea Guardian. So the first book is The Shark Whisperer, which I love. And the other is The Wonderlist Adventures. And the first one is Escape Galapagos.
And I'll just add that this might be Ellen's 21st or 22nd book. But, I talk as a meteorologist, Emily, you know this, in confidence levels. I'm highly confident it's going to be my bestseller.
Dave, is this your first book, Dave?
Yeah. My first book.
Well, congratulations to you both. This is very exciting. I think it's going to be a huge hit. I can't wait to buy it for science teachers that I know, because I know so many of them, and I think they're going to really appreciate it. So I'm going to go put in my pre-order too.
Oh, that's awesome. One of the cool things that AMS, after the broadcast meeting, AMS said that they're very interested in seeing in New Orleans if they can do a bulk book purchase and give it away for the community in New Orleans. So we would love that.
Fingers crossed.
Maybe give a talk and stuff like that.
Yeah.
So no definitive plans yet, but they're talking about it and say, so
we hope so. We hope so. But we would love for people to do that, because again, we think it would be so helpful for educators.
Ellen, Dave, is there anything else you want to add?
Thanks so much for having us. Yeah. And we're, just as we love seeing your excitement, and you're one of the first. I'll be honest, I'm always nervous when there are first readers of a book. And so to see how much you enjoyed it and your enthusiasm is really, really wonderful for us, because you are one of the first people to actually read it.
Oh, I'm honored. I'm so honored. As a meteorologist, like I said, the weather part, I already knew some of it. I didn't know all of it, though. A lot of it was very informative, but it was really cool as like a science enthusiast to learn about some of the ocean stuff that I didn't know about. So I think it's a great book for somebody who's maybe not like science educated, but like really into science and just wants to beef up their knowledge a little bit. And the myth busting behind it alone is great for just like dinner time conversation,
It's so funny. We had a neighbor with their little boy come by the house the other day, and we were sitting out on the deck, and they came around and started talking to us. Well, he ended up curling up his legs, sitting like this, talking to Ellen about 5 feet away from her, saying, "Well, what about this? How about this? I really think I want to be a marine scientist." He was talking about that. So cute.
That has to be the best compliment ever.
Yeah, right. It was great.
I snuck a peek in my son just started middle school. I snuck a peek in his notebook, and they had to write down what they wanted to learn about this year in science. And he wrote meteorology. He didn't tell me he wrote that. I was like, proud mom moment. He just saw Twisters, so I think that might be part of it.
That is awesome.
That is awesome.
Write a little weather fact on his napkin for dinner every night.
Yeah, I'll get the eye roll if I do that, but somebody else is going to have to do the teaching, I think. Maybe Dave, maybe in the book. Well, thank you guys so much. This was so much fun. I wish you the best of luck with this.
Oh, thanks so much.
Thanks, Emily. Thanks.
Really appreciate it.
Yeah, it's great seeing you.
Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes published every Tuesday morning. If you love this episode, please share it with a friend. Listen with your kids as well. You can also now listen to the show on YouTube. Just search the National Weather Desk and find it under the podcast tab. A big thank you to Dave Jones and Dr. Ellen Prager from Storm Center Communications. Make sure you check out their book, Megalodons, Mermaids, and Climate Change. It'll be out in October, but is available for pre-sale now on Amazon. Also, thanks to my son Aaron and daughter Addison for joining me at the beginning of the episode. Best of luck to all that are headed back to school this month. For the National Weather Desk, I'm meteorologist Emily Gracie. Make it a great day.